Welcome back to Honors Calculus. In this video, we'll be continuing our discussion of differentiation rules with some derivatives of trigonometric functions. Sorry, I'm horribly blurry. Sometimes this helps, sometimes it doesn't. We'll see. I don't know. I'm too blurry. Get myself out of the way so that it's less blurry and you can just read what's going on. The derivatives of trigonometric functions. There are two ideas about trigonometric functions that I want to remind you of. The first, from a trigonometry or pre-calculus course you've previously taken, is the angle addition identity. Which says that the sine of alpha plus beta is the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And for cosine, you have a similar rule. The cosine of alpha plus beta is the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Right? That's something that you should have seen in a trigonometry or pre-calculus course previously. I'm going to accept it as something that is known and move on to use it. The other one I want to remind you of is something that we have seen previously in this course, and that is that the limit as x approaches 0 of sine of x over x is equal to 1, and the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. We introduced the squeeze theorem when we were talking about limits very specifically to prove these two statements, or to prove the first one. And then from there, the second one is actually some simple algebraic manipulations away. But with those two ideas in mind, we can prove that the derivative of sine x is cosine x. And the derivative of cosine x is minus sine x. I'm going to circle that one. Warning in advance, proving that is your assignment. I'm not going to go through it. You should be able to work through that proof, and it follows a similar process to the proof that we will be going through. But I want both of these stated in the theorem because they are both incredibly useful, and I'll be using both of them in the future things that we build up. All right. But the derivative of sine of x is, by definition, the limit as delta x goes to 0 of the sine of x plus delta x minus the sine of x all over delta x. And using the angle addition property, this is the limit as delta x goes to 0 of sine x cosine delta x plus sine delta x cosine x minus sine x all over delta x. All right. And now let's do some creative rearranging. I'm going to try to write this out carefully. This is going to be my first term. Sine delta x cosine x all over delta x. And then the stuff I have left is minus sine x and plus sine x cosine delta x all over delta x. Of course, the limit of a sum is the sum of the limits. So I can split this up and separately look at the limit as delta x goes to 0 of sine delta x cosine x all over delta x. And here I'm going to do one more creative thing, and that's factor out a -1. So it's minus the limit as delta x goes to 0. Because I factored out the -1, I changed the SIGN sign. This will be positive, and that will be negative. So I have sine of x minus sine x cosine delta x all over delta x. All right. And now I really get to have some fun. There are a couple of ways you can think about this next step, but they all give you the same result. The way I like to think about it, in this first term here, I'm talking about the limit as delta x goes to 0. And I have this cosine of x. This factor does not involve delta x at all. This factor is constant with respect to delta x. So I can take it and factor it out in front. And then I can do the same thing or something similar over here. I have sine x in a couple of places, which is constant with respect to delta x. So I can factor out that sine x and bring it in front here. And in doing that, I have the cosine of x times the limit as delta x goes to 0 of sine delta x over delta x. And I have sine of x times the limit as delta x goes to 0 of 1 minus cosine of delta x all over delta x. Here's where that squeeze theorem comes in. By the squeeze theorem, that first limit is 1. And by the squeeze theorem, that second limit is 0. So I have 1 times the cosine of x minus 0 times the sine of x, which is just the cosine of x. building off of those rules, the derivative of tangent of x is secant squared x. The derivative of secant x is secant x tangent x. The derivative of cotangent x is the negative of cosecant squared x, and the derivative of cosecant x is the negative of cosecant times cotangent. Sorry, that's not quite enough space there. Let me slide this last one over so I can actually fit it on the screen. The derivative of cosecant x is the negative of cosecant x cotangent x. We can prove these using the quotient rule for derivatives along with the ideas of the ratio and reciprocal identities. So I'm not going to prove all of these again, but let's take a look at tangent. That's the most complicated one. The derivative of the tangent of x, well, tangent is sine divided by cosine. And when you have a quotient, you take the derivative of the numerator times the denominator minus the denominator, or the numerator times the derivative of the denominator. So we have the derivative of sine times cosine minus sine times the derivative of cosine all over the denominator, which in this case is cosine squared. Derivative of sine is cosine, derivative of cosine is minus sine. So we have cosine times cosine plus sine times sine all over cosine squared, which I can simplify and call cosine squared x plus sine squared x all over cosine squared x. But of course, sine squared plus cosine squared is 1. That's the Pythagorean identity. And 1 over cosine is secant. You can prove the other 3 trigonometric derivatives using similar rules. Finally, let's pair these up with the chain rule that we talked about previously, which says that the derivative of f of g of x is f prime of g of x times g prime of x. So if I want to take the derivative of the tangent of x squared minus 5, well, the rule of differentiation says that I want the derivative of tangent evaluated at x squared minus 5. The derivative of tangent is secant squared. And then I want to multiply that times the derivative of x squared minus 5. Derivative of x squared minus 5 using the power rule will be 2x minus 0. And I'll put that in front because that's how we normally treat things. And we get the derivative here is 2x times secant squared of x squared minus 5. A similar problem for you to take a look at I would like you to evaluate the derivative of the cosine of 3x squared plus 7x. Take a few minutes and see where you can get to with this one, and I'll see you in the next video.